Hello everyone, let me teach you queue using linked list in this video. First of all, let me explain you what is queue. Queue is I have explained queue using array in my previous video. If you want, you can watch that and come. Okay. First, queue. What is the meaning of queue? Queue is something called as line, right? Example of queue is line. When you are standing in a hospital or medical shop for buying some medicine, it is called as queue, right? When you are entering first, you will be leaving first. When you are entering last, you will be leaving last, right? Let me show you, explain you this in an image. Okay, explain this is an queue. Okay, if this is first, you will be entering with this and you will be leaving like this. If this is a line, 9 will be leaving first and 4 will be leaving last, right? This is called queue. This is called, we are implementing this in single linked list. Okay, let me show you the program. Okay, first, struct node of int data. We are assigning int data as some variable which we will be using in further process. Okay, and struct node of next, we are creating a space. Okay, and struct node of front and struct node of rear. What is front? What is front? We are allocating some position as front and we are allocating some position as rear and we are allocating some position as next. Okay, and void enqueue. What is the meaning of enqueue? Enqueue is adding element into a queue, that is called enqueue. Okay, we are assigning that as int. What is int? We are passing an argument and that will be, we are declaring the argument here. We are declaring the function here, so it is called function declaration. Okay, and we will be using further. Okay, and while deq while display, we are declaring the functions here and we are entering into the program. And int main, int choice and value, we are we are using it, and so that we are declaring here. And while of 1, for this loop will be continued. What you want, like what operations you want to perform, like in queue, deq, display, or exit. If you enter your choice, the choice will be get your choice will be get by using scanf. And switch choice, we are putting switch choice based on your choice. You will be getting, if your choice is 1, that is, if your choice is enqueue, enter the element to be inserted. Scanf, you are getting the value since the value is here and choice is here. Okay, and choice is you are getting here, so we are declaring here and the value is here. Okay, enqueue of that value. And int x, we are enqueue. By seeing this, it will be first declaration over. Next, by seeing this, it will be going, it will be searching for where the enqueue is. So here we have mentioned void enqueue. So int of x. What is int? This is the data type and this is the value which we are passing this value. Okay, we are getting this value as x. And a struct node asterisk new node, we are creating a new node just because we want to include a value, right? If you want to include a value, like some example, a value, a person, if you want to include, we must we must need a space, right, for that person. So we are creating a new node for that number or that something to enter. Okay, we are creating that space. Okay, it is called new node. Okay, why we are not accessing here? Since because you want this node only for this adding process, for this inserting process. Like for enqueue, in essence, what is enqueue? Adding, inserting element, right? Only for inserting element you need it. So you need not need this new node for every time, so that we are not mentioning in above, we are mentioning it. Okay, struct node new node is equal to struct node malloc of size of struct node. If new node is equal to null, that is, if we are performing all the operations that only in that new node, if that new node after all the operations performed is remaining null, memory allocation failed. Okay, it is printing like that. Okay, and this is basically simple. Then here in the major part, okay, we are assigning this value of x. What is this? This is the value we got from the user, right? This value as new node's data. New node's data is equal to x. And what is the value of new node and next? Will be null. See, this is the new node. If this is a new node, the what is basically a queue? If a person is inserted, he will be inserted only in the last, right? So that new node's data will be x and the new node's next will be null. This is the new node and this node's next will be null. That is called this. Okay, and if front is equal to null, what is front is equal to null? That is, if the element has 0, if the element has nothing, if the queue has nothing, the front is also the same, the last is also the same, the new node is also the same. We are allocating a new node. Okay, we are allocating a new node, and if Front is not present, that is front equal to null. That is no element is present, the front element is also called as the last element, and it is also called as new node. That's all. It is very, very, very simple. If front is equal to null, front element is the new node, and the new node created as front and acts as both front and rear. That's all. Okay. Else, rear's next is equal to new node. New node we are assigning it as rear's next. What is the value of rear? What is the value of rear? First of all, the last element. The last element's next is equal to new node. That is, when we are creating a new node inside some existing node, this is rear, right? Rear's next is equal to new node. That is, when we want to insert another element, rear's next is equal to new node. That is, if it is rear, this is called new node, right? Rear's next is equal to new node. Rear is equal to new node. Then we are assigning that new node as last position. For example, if you are considering this, if the rear position is equal to 7 and if 4 we are adding, if we are adding 4 there, and this becomes rear's next is equal to that new node, right? New node, first 7 is new node, 7 is rear and 4 is new node. Then if we are adding that 4 as new node, then that becomes rear's, what is this? If the rear is in 7, rear's next is equal to 4 and rear is equal to new node. That is, rear, the new node becomes the last position, right? That's all. Okay. Printf enqueued successfully. Why did you queue? First, let me explain you what is the difference between array, queue using array and queue using linked list. In queue using array, we are defining here hashtag max define max of 5. Why we are defining it? That is, when we are using array, we will be we will be having some set of rules that the array must contain some set of elements, right? If we have defined there 5, only we must contain 5 elements. If it is a linked list, we can contain as many elements as possible, as many elements as we want. Okay, that is the major difference between queue using array and queue using linked list, or anything stack using array, stack using linked list also the same difference. Okay, and DQ, as I said before, what is the meaning of DQ? The first person who is entering, the first will be the first person who will be leaving, right? And the first is the first person. Okay, the first will be the first to move. The first person entering will be first to move. Okay, that happens in this code also. If front is equal to null, queue is empty. That is, if there is nothing exists, there is nothing to be taken out, right? And struct node of temp, as we told before, we use new node, right? Here we are using temp. Okay, temporary variable, just because of the following steps we are going to do, right? If we are defining struct node temp, okay, and we are allocating some memory, we are keeping that front is as temp. Okay, we are assigning front as temp. See, listen, we are assigning front as temp. Then we are moving that CS code, front is temp, front is equal to front's next and free of temp. Listen, sorry, front is temp, front is equal to front's next. Then we are moving this value towards this. Understand, this front is moved towards next, and this we are assigning as temp. This is temp. First of all, front is equal to temp. Understand? Then front's position is plus, then front position is equal to front's next. Okay, front is equal to front's next. Then we are freeing up this temp. Temp remains here, right? Temp remains here, and we are leaving this temp right there, and we are joining from this front. Understand? Try to understand. Imagine this is the temporary value we are keeping. We are keeping temp here. If we are doing front equal to front pointer variable, pointer of next, front equal to front's next, then temp will be this, right? Then we are going to free this temp, and this is a front. This will become front, and this will be removed. Try to understand. This is very easy to understand. Try to understand. Front is equal to front's next, temp is equal to front. That is, we are assigning front as temp. We are assigning front as temp. We are assigning front as temporary variable. Okay, temporary variable as we are assigning front as temporary variable. Then we are freeing up that temporary variable. Why display? If front equal to null, what is my left front equal to null? Tell me. And I am asking you, what is the front equal to null? Front equal to null in the sense there is nothing, right? Q is empty, right? And if it is not, that is, if some elements are present, we are assigning front struct node as struct temp is equal to front. That is, we are, as I told before, we are assigning this as front. Okay, then while temp not equal to null. That is, while the temp till the temp goes to this null value, you must do the following while we are that condition we are keeping, and printf percentage d comma temp of data. That is, let me explain you. Printf temps data. What is data here? 9, 1 is 7, 4. These are the data, right? So we are printing that. Temp is equal to temp button. Temps next. Okay, that's all. It's very easy. Then we are moving the temp. First of all, let me say you, we are assigning a temp. Then temp equal to printf percentage d comma temps data. Then we are printing this. Then we are moving this temporary variable here. Then we are what we will be doing. Then printf percentage d comma temps data. Then temp equal to temps next. We are moving here. Printf percentage d comma temps data 7. Then we are moving here till it reaches null. We are moving here. Then we will be printing 4, right? That's all happens here. While temp not equal to null, till it reaches null value, you must print this following. That's all. That's all about the script. About this code. This is very easy. This is very easy. And if you watch Q using array also, this is very useful. So thank you for watching this video fully. Thank you. இப்போ நம்ம வந்து அவுட்புட் பார்க்கலாம். இப்போ வந்து என்ட்ரி சாய்ஸ் கேட்குது. நான் வந்து என்கியூ கொடுக்குறேன். என்கியூ என்னன்னு தெரியும்ல, என்ட்ரிங் நான் சொன்ன மாதிரி இன்சர்ட் பண்ண கேட்குது. 1 2 1 3. டெலிட் பண்ணுறதுக்கு கேட்குது. இப்போ நான் டெலிட் பண்ணுறதுக்கு நான் போடுறேன். டெலிட் என்ன பண்ணும் நீங்களே சொல்லுங்க பார்ப்போம். 1 டெலிட் பண்ணும். நான் டிஸ்பிளே பண்ணுறேன். 1 இல்லை, ஓகேவா? 2 3 மட்டும்தான் இருக்குது. இதுதான் வந்து கியூ யூஸிங் லிங்க் லிஸ்டோட அவுட்புட், ஓகேங்களா? ஸோ தேங்க்யூ ஃபார் வாட்சிங் திஸ் வீடியோ. தேங்க்யூ.